Hi, and welcome back to the deephaven.learn video documentation series. In this video, I'll be covering static applications of deephaven.learn. Deephaven's bread and butter are big and real-time data. Even if data isn't real-time, there is a place for it in the Deephaven data ecosystem. The latest and greatest AI and ML models utilize software systems that are designed to handle data that comes in all shapes and sizes. Your applications should leverage those as well, so let's dive into the world of static data applications that use deephaven.learn. This diagram shows only a subset of the fields in which static data is critical. In AI and machine learning, models are usually trained on static datasets before being deployed in real-time systems. Additionally, feature engineering is largely done on static data in order to pick out the important parts among endless fields of data. Data also must be prepared and validated before it can be processed, and algorithms for doing so are usually designed, implemented, and tested in static systems before any real-time deployment. Even after a real-time model has done its job, engineers will check the model's performance via static analysis. When real-time systems encounter critical issues, data logs are analyzed in a static context in order to find a fix. When using deephaven.learn on static data, there are a few considerations I'll cover in this video. They include the batch size, training AI and machine learning models, visualization and validation, and some common issues you may encounter. When using deephaven.learn, the batch size determines how many rows of data in your table will be pulled in a single update cycle. For a batch size of n, the first update cycle will pull the first n rows from the table. On the next update cycle, rows n plus 1 to 2 times n are up. Your batch size should be chosen with the following in mind. If you're dealing with big data, what kind of hardware are you using? Whether it's a CPU with 4 cores, a GPU with 4096 cores, or a TPU with only 2 cores, how much data can be loaded for processing in a single cycle? Maximum performance is decided largely by your hardware specifications. Training AI and machine learning models may give slightly different results when the batch size changes. Specifically, extremely large batch sizes can be great for unsupervised models, but for artificial neural networks, big batch sizes can result in longer training times with little payoff. In fact, batch sizes that are sufficiently too large can even cause degradation of model performance. Signal processing with deephaven applies the processing to one batch after the next. In smoothing signals, there will be a noticeable set of discontinuities between the end of one batch and the start of the next. You can mitigate this through the use of smart models or through windowed data operations, which require some overhead to properly track data in the constantly shifting window. Static problems are also great for understanding what deephaven.learn truly does. Take this code I have at the bottom of the screen, for instance. I do no data processing in this code, but I print the shape of the NumPy array that my model function will receive. When I run this code, you can see that, on the first few cycles, I receive 2 columns and 8 rows, which is expected. However, on the last batch, there are only 4 rows left in the table, so I end up with those. This simple static example shows an important concept, that the batch size specifies the maximum number of rows you will process at once. This concept is particularly important for real-time data. Make sure your batch size is at least the most rows you expect to receive in a single update cycle. It's hard to show the common issues in static data in a short video like this, but I'll gloss over a few that you should know about. First off, the trade-offs between large and small batch sizes for training AI and machine learning models are well known and documented. Poor model performance can be attributed to this. When performing signal processing, as I mentioned previously, deephaven.learn will not enforce the continuity of your results between batches. The error reporting done by deephaven.learn can be daunting at first, but is like other errors. Buried in the information is the true root cause. You'll likely see references to things like getFutureOffset and _init_. Around that stuff is where you will find your true error. If deephaven runs out of memory to process data with, the system will simply shut down in your browser and the window will go blank. In the session from which you launch deephaven, you'll probably see something that says the words transient failure. What that means is that you ran out of memory. If possible, consider increasing what you make available to Docker. We do have guides for that, and you can find them in the video description below. That covers many of the major considerations when handling static data with deephaven.learn. Check the video description below for relevant links and information that I previously mentioned. Like and subscribe to our video on our channel, and I'll see you in the next video where I'll cover real-time dynamic data.